So let's first talk about some properties of equality. So solving an equation means we're determining the value or values of a variable that make the equation true. So if I have x plus 6 equals 10, we are looking for what number do we add to 6 to get 10 to make that a true statement. Whenever we are solving equations, we have to maintain equality using the properties of equality. So there's one for each type of operation. For addition, if we add a number to one side of the equal sign, we have to add that same number to the other side. That's all it means. So if I add 3 to the left side, I have to add 3 to the right side. Subtraction, whatever I take away from one side, I have to take away from the other side. Multiplication, you guys can probably already figure this out. Whatever I multiply on one side, I have to multiply by on the other side. And division, whatever I divide by on one side, I have to divide by on the other side. And the reason we do this is to maintain a balance on both sides. So let me show you why we do that real quick. So let's say we have the equation x plus 6 equals 13, and I want to know what x is equal to. In order to figure this out, I am going to undo this plus 6. So to undo addition, I would do the opposite, which is subtraction. So I am going to subtract 6 from this 13. So here's 1, 2, 3, 4, 5, 6. What do you notice happened to my balance? Are the two sides equal right now? No. No, they're not. Why are they not balanced? It's okay to say I don't know. Why are they not balanced? Okay. 7 is bigger than 6. Okay, that can be part of it. I only took away the 6 from this side, which means this side right here has a greater value right now. I did not follow the subtraction property of equality. I only subtracted from one side. With equations, what we do to one side of the equal sign, we have to do to the other. So to balance this out, I need to subtract 6 from this right or left side as well. And when I subtract that 6, my two sides balance out. And I can see that in that equation, x is equal to 7, because I'm left with x on this side and 7 of the original 13 on this side. Okay, so that is the properties of equality. what I do to one side of the equal sign, I have to do to the other. If I subtract 6 here, I have to subtract 6 here. If I add 6 here, I have to add 6 here in order to balance things out and keep things equal. Okay. Any questions about that? All right, let's get back into our notes for the day. All right. So let's keep that in mind, and we're going to first solve 2x plus 6 equals 13 using the double number line. So I'm going to go in here, and I'm going to figure out where this 13 would go. So 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, it looks like all the way at the end. So this is 13. Which means that right here is going to be 2x plus 6. Kind of running out of room there. So keeping these properties of equality in mind, okay, I want to decompose 2x plus 6, which would be 2x and 6. And if I decompose this, I have to go backwards 6 to figure out what the other part of that would be. So, and the reason we go, because that's my equation over here, 2x plus 6 equals 13. It was different on the balance. Okay. So to undo this problem and figure out what x is equal to, I have to do the opposite. So the opposite of adding 6 would be to subtract 6. So I'm going to go 1, 2, 3, 4, 5, 6 would be right here. And that's 12, 11, 10, 9, 8, 7. I'm going to go backwards 6 here. 1, 2, 3, 4, 5, 6. And here is my 2x. Okay. So I undid this plus 6 on both the right side and the left side of my equal sign. Now I need to undo multiplying by 2. So what is the opposite of multiplication? Right. So we're going to divide from 0x to 2x into 2 equal pieces. So I need to take 7 divided by 2 as well. So if I have 7 of something, 3, 4, 5, 6, 5, 6, 7, okay? I'm going to divide it into 2 equal groups. So I can see that I would have 1, 2, 3, 1, 2, 3. And then I have 1 left over. So 3 times 2 would be 6, 1. I'm going to add a decimal because I have to split this 1 in half. Okay. So if I split 1 in half, that's going to give me half of 1 in one group and half of 1 in the other group. So 7 divided by 2 would be 3.5. So 1, 2, 3, and a half would be right here. 1, 2, 3, and a half. Here is my x. So in this problem, x is equal to 3.5. And I can go in and I can check it by putting the 3.5 in for x. So 2 times 3.5 would give me 7, plus 6 equals 13. 13 equals 13. This is the correct answer for this problem. Any questions about that one? We're going to look at solving this a different way, okay? And that is by thinking about what we did to x so that we can undo it to find the answer. So 2x plus 6. Well, the first thing I see that we did is we added 6. To undo that, we have to do the opposite of addition, which is to subtract 6. And we also multiplied x by 2. So we multiplied by 2. To undo it, we do the opposite, which is to divide by 2. So this is what we did to x to get to 13. This is what we have to undo in order to find what x is equal to. Any questions about that? So now I'm going to use this to solve for x. So we added 6. I need to subtract 6 from both sides because remember, we're maintaining equality. So I'm not subtracting anything from 2x. 6 minus 6 is going to give me 0. So I can either write plus 0 or write nothing. 13 minus 6, 13, 12, 11, 10, 9, 8, 7. All right, so we undid the addition. Now we need to undo multiplication. So to do that, I divide both sides by 2 to maintain equality. 2 divided by 2 gives me just 1x. And 7 halves as a decimal is 3.5. So I still got the same answer, even though I did it a different way. I did not use the number line this time. You use whichever way makes the most sense to you, okay? If number lines work better for you, do it. If bar models work better for you, do it. If you understand this better, do it, okay? I want you to use the method that benefits you the most or works best for you, all right? All right, let's look at some ways that students solved this problem. Demarius, Calvin, and Isaac each solved 2x plus 6 equals 13 in different ways. So if we look at Demarius' strategy, he divided by 2 first, and then after he divided by the 2, he was left with x plus 3 equals 6.5, and undid the plus 3 by subtracting 3 from both sides, and got x equals 3.5. So he divided everything by 2, subtracted 3, ended up with 3.5. Calvin also started with division, but he only divided 2x by 2 and got x plus 6 equals 6.5. He undid this addition of 6 by subtracting and got x equals 0.5 as his answer. And then Isaac did what we just did. He started by undoing the addition, and then he divided by 2 and got 3.5. Demarius and Isaac got the same answer, even though they used a different method, and Calvin ended up with the wrong answer. So let's look at Demarius and Calvin. Where did Calvin go wrong? What did he forget to do? Because they both started with division. Right. Okay. Calvin forgot to divide this 6 by 2. Okay. If you're going to divide first, you have to divide all of the terms, not just the one where the 2 is. Okay. Or whatever the coefficient is. You have to divide every single term on that side by your divisor. Okay. So that is where he went wrong. If he had divided 6 by 2, he would have got the right answer. Okay. So if we wanted to compare their strategies, we could say Calvin did not divide 6 by 2, which gave him the wrong answer. Okay. So where did he go wrong? He forgot to divide the 6 by 2. Okay. All right. What about Demarius and Isaac? Demarius, we know, started by dividing. Isaac started by subtracting. So he undid the multiplication first. He undid the addition first. Did they both end up with the same answer? Excuse me, Demarius has 3.5. It's a little hard to see, but Isaac has 3.5. So we could say that they solved it in Earth. They solved it differently, but still came up with the correct answer. So even though one subtracted first and one divided first, they still came up with the same correct answer. Okay. So it did not matter what strategy or what we undid first. Yeah, it's a little blurry, the little decimal right there. any questions about these problems? Let's talk about your assignment for today. So, all right. For today, we went over, we did not do this slide, but you should be able to answer this. So what is the inverse of addition? What is the inverse of multiplication? Inverse means opposite, okay? And then we went over slides 3 and 4 together. So you have the answers for those 2 slides once the video is posted. So you will need to do 6, 7, 8, and 9 by yourself. And you are going to solve the equations in 2 different ways. The first way is you are either going to do addition or subtraction first, okay? So if we look at 56 equals negative 10 plus 2x, I need to undo this negative 10 or minus 10. So how am I going to undo minus 10? What would I do to it? What is the opposite of subtraction? Because that's what this negative means, is we're subtracting 10. Right. So we're going to add 10 to both sides of the equal sign first. I want to see your work. You can either work it out on paper and upload a picture of it, or you can work it out on paper and then type it here, or you can just type out your work here, whichever way works best for you. So you're going to solve with addition and subtraction first, and then you're going to solve with either multiplication or division first. 2 different ways for each of the 4 problems. What that is. Any questions about your assignment? I will be